go. Man, my room looks terrible. There we go. Okay. Chapter 1. Question 1. Simplify x to the 5 times x cubed all over x to the 6. That would be x to the 8 over x to the 6, which is x squared. Question 2. Expand x add 3 times x add x take 5. X add 3 times x take 5. That should be x squared add 3x take 5x take 15, which is x squared take 2x take 15. Factorize x squared take 9x add 20. Well, that would be x take 4 times x take 5. Evaluate 16 to the negative 3/4. 16 to the quarter is 2. 16 to the 3/4 is 8. 16 to the negative 3/4 is 1 over 8. Simplify root 50 at root 18. Root 50 is 5 root 2. Root 18 is 3 root 2. So root 50 at root 18 is 5 root 2 at 3 root 2, which is 8 root 2. Question 6. Rationalize the denominator of 6 over 3 take root 3. So multiply the top and bottom by 3 plus root 3. Take care of the denominator first. So 3 take root 3 times 3 add root 3 is 9 take 3, which is 6. So 6 on the denominator. And on the numerator, we're doing 6 times 3 add root 3. So 18 add 6 root 3. 18 add 6 root 3. And then all of that is divided by 6. So 3 add root 3. 3 add root 3. Chapter 2. Quadratics. Solve x squared take 5x take 14 equals 0. X squared take 5x take 14 equals 0. So that would be x take 7 times x add 2 equals 0. And if you have x take 7 times x add 2 equals 0, then x is either 7 or negative 2. Write x squared add 6x add 2 in the form x add p all squared plus q. So it's x squared add 6x add 2. Now we need to complete the square. So it's going to be x add 3 all squared, which generates an extra 9, so you have to take that away. So x add 3 all squared take 9, add 2. So x add 3 all squared take 7. X add 3 all squared takes 7. Question 9. Use the quadratic formula to solve x squared take 4x add 1 equals 0. X squared take 4x add 1 equals 0. Well, the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, a is 1, b is negative 4, and c is 1. And thus, substituting. The discriminant in this case is b squared minus 4ac, and sorry, that's the discriminant in general, but in this case it would be the square of negative 4 minus 4 times 1 times 1, so that would be this. That would be 12. That would be 12. That's the discriminant. Anyway, so we have 4 plus or minus root 12 all over 2. 4 plus or minus root 12 all over 2. Now root 12 is 2 root 3, so it's 4 plus or minus 2 root 3 all over 2, which is 2 plus or minus root 3. 2 plus or minus root 3. That's using the QF to solve x squared minus 4x plus 1 equals 0. Question 10. Find the values of k for which x squared at kx at 9 equals 0 has equal roots. Find the values of k for which x squared at kx at 9 equals 0 has equal roots. So in that case, I mean, quite obviously here you can see that x at 3 all squared equals 0 has equal roots, or one repeating root, namely negative 3, and therefore k would be either 6 or minus 6. I'm going to write plus or minus 6 to find where x squared at kx at 9 equals 0 has equal roots. Alright, question 11. We're going to state the minimum point of y equals x squared take 8x at 3. State the minimum point of y equals x squared take 8x add 3. Now to do so, we need to find the line of symmetry. And the line of symmetry is minus b over 2a. So in this case, that would be 8 over 2, which is 4. So x equals 4. But anyway, that's the line of symmetry. Now, what's the actual minimum point? Of y equals x squared take 8x add 3. You sub in 4, so you would get 4 squared take 8 times 4 add 3. 4 squared take 8 times 4 is negative 16, and then add 3 to get negative 13. So, if I'm not mistaken, the minimum point of y equals x squared take 8x add 3 should be 4 minus 3. Now for question 12, a ball's height is h equals 20t take 5t squared. After how many seconds does it return to the ground? After how many seconds does it return to the ground? So the height is, beg your pardon, yeah, the height h is 20t take 5t squared. So we're going to factor out 5t. And so we'll have h equals 5t all times 4 take t. 4 take t. 5t all times 4 take t. And if that's the case, then where it equals 0, as in where the height is 0, that would be at 0 seconds, i.e. the start of its journey, or at 4 seconds, the end point of its journey, the end time of its journey. So 4 seconds. Okay, chapter 3, equations and inequalities. Solve simultaneously y equals 2x at 1 and 3x at y equals 11. Y equals 2x at 1 and 3x at y equals 11. Y equals 2x at 1 and 3x at y equals 11. So we're going to grab the 2x at 1 and put it where y is. So we'll get 3x at 2x at 1 equals 11. And that becomes 5x at 1 equals 11. So x is clearly 2. And if x is 2, we're going to substitute that into the first equation, which is y equals 2x at 1. And when we do so, we get that y is equal to 5. So the solution to to this system of equations is 2, 5. And this system of equations is y equals 2x at 1 and 3x at y equals 11. Question 14. Solve simultaneously y equals x at 3 and y equals x squared at 1. So we've got to solve simultaneously that y equals x at 3 and y equals x squared at 1. So we're going to pick up x at 3 and put it into the second equation. So we have y equals x at 3 all squared at 1. And when you sort that out, you have, well, you're trying to, just give me a second now. Oh, beg your pardon. That's actually completely wrong. Okay. Restart. We've got to solve simultaneously the pair of equations y equals x at 3 and y equals x squared at 1. So we're going to pick up x at 3 and put it in the y of the second equation. So we have x at 3 equals x squared at 1. So x squared minus x minus 2 equals 0. X squared minus x minus 2 equals 0. And therefore, factorizing, x minus 2 times x at 1 equals 0. So x should be 2 or negative 1. 2 or negative 1. Now if x is 2 or negative 1, let's now substitute those values into the first equation, which is y equals x at 3. Well, that gives us the solutions, the pair of points that are solutions, which is 2, 5 and negative 1, 2. 2, 5 and negative 1, 2. And that's the solution to the pair of simultaneous equations y equals x at 3 and y equals x squared at 1. Okay, next. How many times does the line y equals x at 5 meet the curve y equals x squared at 3x at 6? How many times does the line y equals x at 5 meet the curve y equals x squared at 3x at 6? Okay, so you have to solve it like you would a pair of simultaneous equations and then see if it has any solutions whatsoever. So we're going to pick up x at 5 and put it where y is in the second equation. So we're going to have x at 5 equals x squared at 3x at 6. And if that's the case, then x squared at 2x at 1, x squared at 2x at 1 is equal to 0. And that's a perfect square. It's the square of x at 1. So the straight line is a tangent to that parabola, that quadratic. And where does it intersect? Well, if x squared at 2x at 1 is equal to 0, then we factorized it as x at 1 all squared equals 0. So x is negative 1. And then we just subbed that into the first equation, which is y equals x at 5. And when we sub that in, we get that y is equal to 4. So it should be 1, 4. Yep, 1, 4. And, all right, so I'm going to write that down. And what does that solve? That solves the pair of simultaneous equations y equals x at 5 and y equals x squared at 6. Y equals x at 5 and y equals x squared at 6x at 9. No, darn it. Beg your pardon. Y equals x at 5 and y equals x squared at 3x at 6. Yeah. Alright, next up. We have to solve... It's already gone. We have to solve 3 open brackets x minus 2 is less than x at 4. 3 open brackets x minus 2 is less than x at 4. So expanding on the left, we have 3x minus 6 is less than x at 4. So 2x minus 6 is less than 4. So 2x is less than 10. So x is less than 5. X is less than 5. And that should be a solution. X is less than 5 should be a solution to 3 open brackets x minus 2 is less than x at 4. There you go. Hello. All right, question 17. Solve x squared take 5x add 6 is greater than 0. Solve x squared take 5x add 6 is greater than 0. So we can factorize this quadratic as x minus 2 times x minus 3 is greater than 0. And then solving it like an ordinary quadratic, we get the roots being 2 and 3, but we need it to be greater than 0. It's a quadratic which opens upwards. So x must be greater than 3, or x must be less than 2. And that should solve that quadratic inequality, which was x squared minus 5x add 6 is greater than 0. Yes. Question 18. For which values of x does the graph of y equals x squared lie below the graph of y equals 4x? For which values of x does the graph y equals x squared lie below the straight line of y equals 4x? Yeah. Alright, so what we do is we just equate them. So we get x squared is equal to 4x. Then move the 4x to the other side, so x squared minus 4x equals 0. Then factor out x, so we have x times x take 4 equals 0. And then x is equal to either 0 or 4. And the parabola is like that, and the straight line cuts through it like that. So the answer to this question is x being strictly between 0 and 4. Question 19. Does the point 1, 2 lie in the region satisfying both y is greater than x squared and y is less than x at 3? Does the point 1, 2 lie in the region satisfying the pair of equations y is greater than x squared and y is less than x add 2. No, x add 3. Okay. Alright, so I guess what we need to do is we just need to substitute in the coordinates of that point into both of them. If we can just visualize it, and that should be fine. Alright, so yes, 1, 2 is certainly above the parabola, but is it below the line? Y is less than x add 3. Is it below the line? Is 2 less than 1 add 3? Yes, 2 is less than 4. So, therefore, it satisfies it. Yes. Okay. Chapter 4, Graphs and Transformations. Where does the curve y equals x times x minus 2 times x add 3 cross the x-axis? It crosses the x-axis at 0, 2, and negative 3. Or to put them in order, negative 3, 0, and 2. And what was the question? The question was, where does the curve y equals x times x minus 2 times x plus 3 cross the x-axis? Next, how many real roots does y equals x squared minus 1 all times x squared minus 4 have? We notice that we can use the difference of two squares formula, or identity rather, and apply it to both of the factors. So it becomes y equals x minus 1 times x add 1 times x take 2 times x add 2. And thus it has 4 roots, plus or minus 1 and plus or minus 2. Question 22. State the two asymptotes of y equals 3 over x. As in, the imaginary lines that the graph of the curve approaches but never intersects. But it can get arbitrarily close. The answer to this question is x equals 0 and y equals 0. It is the pair of axes themselves. And the question was, state the two asymptotes of y equals 3 over x. Question 23. In how many points does y equals 1 In how many points does y equals 1 over x intersect y equals x? In how many points does y equals 1 over x intersect y equals x? We can visualize it as the hyperbola. All right, and the answer is just simply 2. Crosses it twice. And where does it cross it exactly? Well, at 1, 1 and -1, -1. Question 24. State the equation of y equals x squared after a translation of 2 units right and 3 units up. So to make it move 2 to the right, you go in where x is and you take away 2. So it should transform into y equals open brackets x minus 2 all squared, but then you have to make it move 3 up. So y equals open brackets x minus 2 all squared plus 3. And that way of encoding it sort of lets you see what the transformation actually was, but without a doubt they would want it to be expanded and cleaned up. So y equals x squared minus 4, y equals x squared minus 4x plus 4 plus 3, so y equals x squared minus 4x plus 7. Y equals x squared minus 4x plus 7. And that's for transforming the curve y equals x squared by translating it 2 units to the right and 3 units up, and it should be y equals x squared minus 4x plus 7. Question 25. The point 6, 5 lies on y equals f of x. Where does it move to on the curve on y equals f of 2x? The point 6, 5 lies on y equals f of x. Where does it move to on the curve y equals f of 2x? Okay, so this should be a horizontal compression by a factor of 2. For a sine wave, for example, it would become squashed like that. And therefore it moves further inwards. So 6, 5 should move to 3, 5. The answer is 3, 5. And that's answering the question, where does 6, 5 move to? That's answering the question, if 6, 5 lies on the curve y equals f of x, where does it move to after the transformation y equals f of 2x? Question 26. In which axis does y equals negative f of x reflect the graph y equals f of x? So it should reflect it in the x-axis, because every single y coordinate has become its own negative and hopped across the x-axis. That's answering the question, in which axis does the curve y equals f of x reflect into y equals negative f of x? Chapter 5. Find the gradient of the line that passes through 1, 2 and 4, 11. So you apply the formula of change in y over change in x. So the change in y is 11 take 2, and the change in x is 4 take 1. And 11 take 2 is 9, and 4 take 1 is 3. So 9 over 3, which is 3. The answer is 3. That's the gradient of the line that passes through 1, 2 and 4, 11. Find the equation of the line with gradient 2 through the point 3, 1. Find the equation of the line with gradient 2 through. Find the equation of the line with gradient 2 through the point 3, 1. So we can use y equals mx at c. Put 2 where m is. Put 1 where x is, and put 3 where x is, and put 1 where y is. So we get 1 equals 2 times 3 plus c. So c should be negative 5. So the full equation is y equals 2x minus 5. Y equals 2x minus 5. And that's the equation of the line with gradient 2 that passes through the point 3, 1. Question 29. State the gradient of any line that's perpendicular to y equals 4x minus 7. So remember that the gradient of a line that is perpendicular to y equals mx at c would have a gradient that's the negative reciprocal, as in minus 1 over m. Applying that to y equals 4x take 7, it should be negative a quarter. And that's the gradient of a line that is perpendicular to y equals 4x take 7. Question 30 says find the distance between 1, 2 and 4, 6. Find the distance between 1, 2 and 4, 6. So you need to do the change in x squared plus the change in y squared and then square root the result. So that's 3 squared at 4 squared and all of that square rooted, which gives you 5. And that's the distance between the points 1, 2 and 4, 6. A taxi charges £3. A taxi charges £3. Oh my goodness me. Okay. A taxi charges £3 plus £2 per mile for a journey. Find the cost of a 5-mile journey. So it should be £3 plus £2 multiplied by 5, which is £13. State the center and radius of the circle x take 2 all squared plus y add 1 all squared equals 25. The center is 2, negative 1 and the radius is 5. And that's for the circle that is specified by the equation x take 2 all squared plus y add 1 all squared equals 25. Question 33, find the center and radius of x squared at y squared, take 6x at 4y, take 3 equals 0. Find the center and radius of the circle specified by x squared at y squared, take 6x at 4y, take 3 equals 0. So we're going to gather together the x terms. So we have x squared take 6x. And then for the y terms, we have y squared at 4y. And then the little constant on the end is minus 3. Now we're going to complete the square of those. So we have x take 3 all squared. And then y at 2 all squared. And then notice that we generate an extra 9 out of nowhere. So we've got to take away 9 for the x terms. And then for the y terms, we've got to take away 4. So we end up taking away 13. And if we take away 13, and then we have to then take away the extra 3. So we take away 16 and we move that to the right hand side. So we end up with x minus 3 all squared plus y add 2 all squared equals 4 squared. And therefore the center is 3, negative 2, and the radius is 4. The center is 3, negative 2, and the radius is 4. And that's finding the center and radius of the circle specified by the equation x squared at y squared, take 6x, add 8y, take 3 equals 0. And we ended up with 3, negative 2 as the center and 4 as the radius. Yeah. All right, question 34. Does the line y equals 7 intersect the circle x squared at y squared equals 25? Does the line y equals 7 intersect the circle x squared at y squared equals 25? Y equals 7 is a horizontal line passing through the point 7 on the y-axis, horizontal line. X squared at y squared equals 25 is a circle centered upon the origin with a radius of 5. And therefore, we can visualize that it clearly does not pass through. We have to find the gradient of the tangent to the circle x squared at y squared equals 25 at the point 3, 4. Now, we already have a point on the circumference of the circle, namely 3, 4. And we need the gradient of the tangent. So we have to understand that the radius, that we can visualize the radius of the circle emanating from the origin and connecting to the point 3, 4. And that will have a gradient of 4 over 3. As for the tangent, that would be perpendicular, and therefore it would be negative 3/4. So we can use y equals mx at c now. So y equals negative 3/4 of x plus c. But then we have to put in 3, 4 to get what the value of c is, the y-intercept. So y equals negative 3/4 x plus c. So 4 equals negative 9/4 plus c. So 4 plus 9/4, so 6 1/4 equals c. So we end up with a conclusion that the tangent is y equals negative 3/4 x plus 6 1/4. And y equals negative 3/4 x plus 6 1/4 is the equation of the tangent that passes through the point 3, 4 of the circle x squared and y squared equals 25. Okay. Question 36, what size is the angle of a semicircle? So I think that's pretty obviously 180 degrees, but they may be asking for it in radians, in which case it's also pi radians. Chapter 7, Algebraic Methods. We have to simplify x squared take 4 over x add 2. So what we're going to do is we're going to factorize the numerator, so we get x add 2 times x take 2, and all of that's going to be over x add 2. So we're going to cancel x add 2, and so we just get x minus 2. But be very careful about this, because this is just working with the expression raw and not thinking about whether or not it can evaluate for a given value of x, in which case we need to be very careful to not somehow now include points in the domain of x. So the answer was x minus 2, and that was simplifying the algebraic expression x squared minus 4 over x plus 2. Find the quotient when x cubed take 3x squared add 1. Find the quotient when x cubed take 3x squared add 4 is divided by x add 1. X cubed take 3x squared add 4 is divided by x add 1. Okay, so we get x squared on the top. Minus 4x. X squared minus 4x. Minus 4. X squared minus 4x minus 4. I believe that's the answer when you divide x cubed minus 3x squared minus 4 by x add 1. Oh darn it, it's plus 4. Okay. Next, is x minus 2 a factor? Is x minus 2 a factor of x cubed take 3x squared add 4? My question is x minus 2 a factor of x cubed minus 3x squared add 4? So what you do is you substitute in the value of 2 into x cubed minus 3x squared add 4, and we get 0. So it actually is a factor. What is a factor though? X minus 2 is a factor of x cubed minus 3x squared plus 4. Question 40. Give a counterexample disproving the claim that all prime numbers are odd. The obvious counterexample is 2. Question 41. If n is odd, is n squared odd or even? If n is an odd integer, is n squared odd or even? Well, I think we know from elementary mathematics that odd times odd equals odd, but let me prove that. An odd must fit the form 2k plus 1, where k is an integer. Now, if n is odd, then we can express it as 2m plus 1, where m is an integer, and then we can square 2m add 1 to get 4m squared add 4m add 1. And then we can factor out the 2 from the first two terms, so we get 2 open brackets 2m squared add 2m close brackets plus 1. Now what's inside the brackets there, 2m squared add 2m, that's an integer, right? And therefore it satisfies the form of an odd. So yes, it's odd. And that proves it rigorously. Chapter 8. Write down the full row of Pascal's triangle that begins 1, 4. So that would be 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. And that would of course be the 5th row of Pascal's triangle. Question 43. Evaluate 7 choose 2. Evaluate 7 choose 2. Now, there is a big fancy formula, n factorial over n minus r factorial times r factorial on the, that's okay. Numerator is n factorial, denominator is r factorial times n minus r factorial. Okay, you could use that formula if you wanted. However, note that we can also use the triangle numbers if we are so inclined. But, you know, I also happen to know the rows of Pascal's triangle. It goes 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. And then next would be 1, 7, 1, 7, 21. So the next one would be 21. Now, as for triangle numbers, well, those go 1, 3, 6, 10, 15, 21. So it would be the 6th triangle number, actually. That's how you calculate it. Find the coefficient of x in 2 add 3x all to the power of 4. Is that right? Yeah, 2 add 3x all to the power of 4. All right, that would be 4 choose 1, which is just 4. 4 multiplied by the cube of 2 multiplied by 3x. So 4 times 8, so 32. And 32 times 3x is 96, so 96x. So 96 is the coefficient, and that's the coefficient of x in 2 add 3x all to the power of 4. Question 45, find the coefficient of x squared in 1 add 2x all to the 5. The coefficient of x squared in 1 add 2x all to the 5. Alright, so the 1 doesn't matter. You would raise 2x to the power of 2, but you have to multiply that by 5 choose 2. And 5 choose 2 is 10. So it'd be 10 times 25x squared, so 250. So rather, that term that we're looking for is 250x squared, and the coefficient of x squared there is clearly 250. And what was the question? The question was, find the coefficient of x squared in 1 add 2x all to the power of 5. Okay. It says use the expansion of 1 add x all to the 4 to find the expansion of 1.01 to the 4, to estimate the expansion of 1.01 to the 4 to 4 decimal places. 4 decimal places. Right. Now, when you expand 1 add x all to the 4, that would just be 1 add 4x add 6x squared add 4x cubed add x to the 4. And if we consider x to be 0.01, then we know what we know how to raise that to the power of 2, 3, and 4, and so on. Anyway, to cut a long story short and to cut to the chase, it should be 1 point 1.04060401. And therefore, to 4 decimal places, as required, it should be 1.0406. That's using the expansion of 1 add x all to the 4 to estimate the value of 1.01 to the 4 to 4 decimal places. Chapter 9, trig ratios. A triangle has sides 5 and 7 with the 60-degree angle between them. Find the length of the third side. Alright, so we can use the cosine rule, which says a squared equals b squared plus c squared minus 2bc cos a, where a is the angle between them. And it's saying that the angle between them is 60 degrees, and the cosine of 60 degrees is a half. So, a squared, which is our side that we're actually going after, is 5 squared add 7 squared, take 5 times 7 times a half. Now 5 squared add 7 squared is 25 add 49. 25 add 49 is 74, so it would be 74 take 35 over 2, so 74 takes 17.5. 74 takes 17.5, so 56.5, and then we have to square root that. Square root 56.5, and that's approximately 7.5. And that's the answer to finding the third side in a triangle whose sides are 5 and 7, and the angle between them is 60 degrees. Okay. In a triangle where side A is 10 and angle A is 30 degrees and angle B, goodness me, I'm already lost. In a triangle where side A is 10 and angle A is 30 degrees and angle B is 90 degrees. In a triangle where side A is 10 and angle A is 30 degrees and angle B is 90 degrees, find side B. Okay, so we're visualizing it. And sine of 30 degrees is a half. I mean, it's the 30, 60, 90 triangle, like, obviously. But I just have to remember how that looks. Yes, I think it looks like this, where the hypotenuse has a length of 2, the opposite side has a length of 1, and the adjacent side has a length of root 2. No. Correct. Self-correct. Alright, so the hypotenuse has a length of 2, the opposite side has a length of 1, and the adjacent side has a length of root 3. Because the square of root 3 plus the square of 1, all square rooted, is 2. Alright, so that makes sense. And therefore, if the smaller side there is 10, I mean, it must simply be root 3 multiplied by 10. Root 3 multiplied by 10. Find the area of the triangle with sides 6 and 8 and included angle of 30 degrees. So we're going to use the area formula, which says that the area is half of A times B times the sine of C, and C is the angle between sides A and B. Alright, so 6 times 8 times the sine of 30 degrees, that's what the answer would be. Sine of 30 degrees is a half, so it would be 6 times 8 times a half, which is 24. That would be the area. That would be the area. No, because then you have to half that. So it would be 12. 12 square units is the area of a triangle with sides 6 and 8 and the angle between them being 30 degrees. Question 50. What is the largest side of the triangle with sides of length 3, 4, and 5? What is the largest angle of the triangle with sides of length 3, 4, and 5? Well, logically, because that's a Pythagorean triangle, it should be 90 degrees. state the period in degrees of the function y equals tan of x. Tan of x has a period of 180 degrees. State the maximum value of y equals 3 times sine of x plus 2. State the maximum value of y equals 3 times sine of x plus 2. Okay, so multiplying it by 3 just stretches it vertically by a factor of 3. So the maximum should be 3 in that case, but then you have to add 2, and that translates it upwards by 2 units. So the new maximum is 5. And that's the maximum of the graph y equals 3 times sine of x plus 2. The maximum is 5. Chapter 10. Find the exact value of sine of 150 degrees. Alright, so that should be 30 degrees before 180 degrees, and therefore it's also going to be a half. That's the exact value of sine of 150 degrees, a half. Question 54. State the exact value of tan of 60 degrees. That should be root 3. That's the exact value of tan of 60 degrees, root 3. Simplify 1 take cosine squared of x all over sine of x times cosine of x. Now we're going to use the identity that sine squared x at cos squared x equals 1 to rewrite the numerator as sine squared x. So it's sine squared x over sine x cos x. Cancel sine x on the top and the bottom, so we get sine x over cosine x. And that simplifies to, by definition, tan of x. And that's us simplifying 1 minus cos squared x over sine x cos x. So sine of x equals a half for x between 0 and 180 degrees inclusive. Sine of x equals a half. That's what we're trying to solve for x between 0 and 180 degrees inclusive. Alright, that should be 30 degrees and 150 degrees, if you consider the camel hump, as I like to nickname it. Okay. Solve cosine of 2x equals a half for x between 0 and 180 degrees inclusive. Okay, alright, so if we're doing cosine of 2x, that's actually going to compress the graph. Yes. Compress the graph horizontally by a factor of 2. So it'll be squashed, and its new period will be 180 degrees. And we're supposed to solve cosine of 2x is equal to a half. Yeah, cosine of 2x is equal to a half. And therefore, the answer should be, well, instead of being the ordinary 60 degrees and 300 degrees, it's now going to be 30 degrees and 150 degrees. And that's for solving cosine of 2x is equal to a half for x between 0 and 180 degrees inclusive. Oh, whoops, that's actually 58. Solve 2 sine squared x. Solve 2 sine squared x equals sine x for x between 0 and 180. No, for x greater than or equal to 0, but less than 180. And that's for 2 sine squared x equals sine x. Okay. Right, okay, so we're going to subtract sine x from both sides. So we're going to get 2 sine squared x take sine x. And then we're going to factor out sine of x. So we get sine of x times 2 sine of x take 1. Equals 0. And when it's sine of x equal to 0 in the region in the interval specified, only at 0. That's for the first factor. Now for 2 sine of x take 1, when is that equal to 0? Well, that's equal to 0 when sine of x is equal to a half, and in that specified interval that should be 30 degrees and 150 degrees. So the full solution set should be 0 degrees, 30 degrees and 150 degrees. Hello. And that's for the problem where we have 2 sine squared x equals sine x, and we have to solve it between 0 and 180, where we include 0 but exclude 180. All right. Vectors now. If vector A is 3i add 4j, vector B is I take 4j, what is vector A plus vector B? Right? Yes. If vector A is 3i plus 4j, and vector B is I take 4j, what is vector A plus vector B? That would be 4i. It would just simply be 4i. Find the magnitude of the vector 6i take 8j. Find the magnitude of the vector 6i take 8j. So what you do is you just square the magnitude of the component vectors. Square the magnitude of the horizontal vector and square the magnitude of the vertical vector. Then add those together and take the square root of that. It's basically the Pythagorean theorem. So 6 squared add the square root of negative 8 is 36 at 64, which is 100, and then square root that and we get 10. That's the magnitude of the vector 6i take 8j. If A is the point 1, 2, and B is the point 4, 6, find the vector A to B. Alright, so it should be the instruction packet on how to get from point A to point B. Alright, how do you get from 1, 2 to 4, 6? Well, you add 3 in the x direction and 4 in the y direction. So A to B is 3, 4. If you're given the points if you're given the point A, which is 1, 2, and the point B, which is 4, 6, what is the direction vector A to B? It should be 3, 4. The point A has position vector 8i plus 6j. Find the midpoint of the direction vector OA. So if it's just simply 8i plus 6j, it should be 4i plus 3j. A particle has velocity 3i plus 4j meters per second. Find the magnitude of its velocity in meters per second. So we just apply the Pythagorean theorem again, and we're obviously going to get 5 meters per second, and that's for the particle that has a velocity vector of 3i plus 4j meters per second. Chapter 12, differentiation. Find the gradient of y equals x cubed at the point x equals 2. Now, y prime equals 3x squared, y prime equals 3x squared. Then we sub in 2 to get the gradient, and that should be 12. All right, so for the curve y equals x cubed at the point x equals 2, the gradient is 12. Evaluate the limit as h approaches 0 of x at h all squared. Take x squared all over h. Okay, so this is sort of like a standard differentiation from first principles results, and the limit is just simply 2x, because we're trying to find the derivative of y equals x squared in this case. Differentiate y equals 4x cubed, take 2x at 7. We're going to try and differentiate y equals 4x cubed, take 2x at 7. And so we say y prime equals 12x take 2. Y prime equals 12x take 2. No, wrong. 12x squared take 2. And that's for differentiating y equals 4x squared. Y equals 4x squared minus 2x plus 7. Find the equation. Find the equation of the tangent to y equals x squared at the point 3, 9. Find the equation of the tangent to the curve y equals x squared at the point 3, 9. So y prime is equal to 2x. So sub in 3 to get the gradient of the tangent. Sub in 3 and we get 6. That's the gradient of the tangent. The gradient of the tangent is 6. All right, and now we have a gradient of a line and a point on a line. The gradient is 6 and the point is 3, 9. So we're going to use y equals mx at c. So y equals 6x at c. So 9 equals 6 times 3 at c. So c is equal to 9. And therefore the equation of the tangent is y equals 6x add 9. Y equals 6x add 9. And that's for finding the equation of the tangent to the curve y equals x squared at the point 3, 9. For which values of x is y equals x squared take 6x an increasing function? So we know that it passes through 0 and 6. And we know that the line of symmetry is obviously 3. And so it's for x being greater than 3. We don't need calculus for that. Find the second derivative of y equals x to the 4. The first derivative, or y prime, is 4x cubed, and the second derivative is 12x squared. That's the second derivative of y equals x to the 4, 12x squared. So y double prime equals 12x squared. We're going to find the stationary point now of y equals x squared take 4x add 1 and state its nature. Y equals x squared take 4x add 1, and we're going to state its nature. So y prime equals 2x take 4. And when is that equal to 0? That's equal to 0 when x is equal to 2. And then we can just pick up 2 and put it into y equals x squared take 4x add 1. So we get 1. So 2, 1 is the stationary point, and its nature is that it's a minimum. Wait, what is that the stationary point of? Oh, y equals x squared minus 4x plus 7. No! Y equals x squared minus 4x plus 1. Y equals x squared minus 4x plus 1. Beg your pardon. #71. A volume grows according to v equals t cubed. A volume grows according to v equals t cubed. Find the rate of change of v when t is equal to 2. A volume grows according to v equals t cubed. Find the rate of change of v when t is equal to 2. So we need to do dv by dt. dv by dt is 3t squared. Then sub in 2. And we get 12. So the volume is changing at a rate of 12 cubic units per temporal units. 12, whatever those happen to be in this case. And that's the rate of change for v equals t cubed when t is equal to 2. Now, integration. All right, integrate x to the 4 with respect to x. So integral x to the 4 dx is 1/5 of x to the 5 plus c. 1/5 of x to the 5 plus c. Find the integral of 6x squared take 4x dx. Find the integral of 6x squared take 4x dx. Okay, that'll be 2x cubed take 2x squared plus c. 2x cubed take 2x squared plus c. And that's the integral of 6x squared take 4x dx. Given that dy by dx equals 2x and the curve passes through 1, 5, given that dy by dx equals 2x and the curve passes through 1, 5, find y. Well, if dy by dx is equal to 2x, then integrating that, we get x squared at c, and it passes through 1, 5. All right, then c must be 4. So y must be x squared at 4. Y is x squared at 4. And that's finding y when we're told that dy by dx is equal to 2x and that the curve passes through 1, 5. Question 75, evaluate from 0 to 2, 3x squared dx. Evaluate from 0 to 2, 3x squared dx. So this is definite integration. So we integrate like normal. 3x squared, okay, the integral of that will just simply be x cubed. Will it? Oh yes, it will. Beg your pardon. It'll be x cubed. And we have to integrate, we have to evaluate that between the limits 0 and 2. So that would be 8 minus 0. So the answer is obviously 8. And that's the answer to integrating 3x squared dx from 0 to 2. Next up, we have to find the area under the curve y. We have to find the area under the curve y equals 2x from x equals 0 to x equals 4. Alright, so for this one we don't need calculus. We can just understand that it's going to be a triangle, a right triangle. We sub in 2 and we get 8. So that's the height of the triangle. And the base is 4. So 8 times 4 divided by 2, so 16. 16 is the evaluation of the integral of y equals 2x for x equals 0 to x equals 4, if you like. Next up, we have to evaluate the integral from -1 to 0 of x cubed dx. Now, x cubed dx, when integrated, becomes a quarter of x to the 4. And we have to sub in 0. Quarter of x to the 4. Right, 0. Okay, so that's 0. And then we have to sub in -1. Okay. So x -1 all to the 4 is 1, and then a quarter of that is quarter, so it's obviously just a quarter. And that's evaluating the integral from -1 to 0 of x cubed dx. Next up, find the area enclosed between y equals x squared and y equals x. Y equals x squared and y equals x, they obviously cross at 1, 1. And alright, so for the parabola, the area between the curve and the x-axis, the integral is a third of x cubed. So it's a third, beg your pardon, it's a third. I think I should know that. So it's a half take away a third, and a half take away a third is simply, come on, a sixth, of course. And that's the area enclosed by the curve y equals x squared and the straight line y equals x. Chapter 14, Exponentials and Logarithms. Solve 2 to the x equals 32. Well, obviously, x is equal to 5. State the gradient of y equals e to the x at the point where x is equal to 0. Alright, so dy by dx is equal to e to the x. And then subbing in 0, we get the answer of 1. A population is modeled by p equals 100 times e to the kt. Find the population when t is equal to 0. When t is equal to 0, we get e to the k times 0, which is e to the 0, which is 1, and therefore the population at t equals 0, or at the very beginning, is 100. Evaluate log base 3 of 81. Evaluate log base 3 of 81. In other words, to what power must we raise 3 in order to get 81? The answer is 4. Evaluate log base 10 of 4 plus log base 10 of 25. We can use the log laws, so it's going to be log base 10 of 4 times 25, which is log base 10 of 100, which is 2. And that's the answer to log base 10 of 4 plus log base 10 of 25. Solve 5 to the 2x equals 125. 5 to the 2x equals 125. Well, clearly 2x is equal to 3, and so x is equal to 3 over 2. Solve natural log of x equals 2, giving an exact answer. In other words, to what power must I raise e in order to get, I mean the answer is e squared, right? Log base e of e squared is equal to 2, so it's just e squared. Y equals a to the xn. Now plotting log y against log x gives a straight line. What is its gradient? Well, the gradient would simply be a. Okay, and now we have to check. Nearly there. What? The angle in a semicircle? Oh, they're talking about the triangle. Of course it's 90 degrees, yes. Didn't know they were talking about that. Wasn't specified. Uh, 45, I'm sorry. Need to check that. Yeah, 47 as well. And 48. Wow. 49 is fine. 50 is fine. No, 59 is not fine. Alright, so some inaccuracies, but overall it's pretty good. Alright, so what's left to do now is to go back and check why, or rather to correct, self-correct. Oh, that makes sense. That makes sense. I wasn't even thinking for that one. Okay, I understand now why it would be N. Yep. Question 77. Oh, I see. So they want a negative area now. Interesting. Okay, yes. The difference between evaluate and find the area. It's a key difference. Question 70. Oh, that just seems like a silly mistake. 67. That's fine. And that's all good.